The Farey sequence, introduced by the British geologist John Farey in 1816, is a deceptively simple but very rich mathematical idea. For a given positive whole number called the order, the Farey sequence of that order contains every fraction between 0 and 1 that cannot be reduced further, and whose denominator is no larger than the order. These fractions are listed from smallest to largest. For example, the Farey sequence of order 5 includes 0 over 1, 1 over 5, 1 over 4, 1 over 3, 2 over 5, 1 over 2, 3 over 5, 2 over 3, 3 over 4, 4 over 5, and 1 over 1. Farey noticed a striking pattern. In any such sequence, if you take two neighboring fractions, like a over b and c over d, then b times c minus a times d always equals 1. This property was later proved by Augustin Louis Cauchy, who also showed that the fraction you get by adding the numerators and adding the denominators, called the mediant, lies strictly between the two original fractions and will appear in some higher-order sequence. The Farey sequence connects to number theory through a function called Euler's totient. The number of new fractions added when you increase the order by 1 equals the totient of that new order, which counts how many smaller positive integers are coupling to it. So the total number of fractions in the Farey sequence of order n is 1 plus the sum of the totents from 1 up to n. Beyond its elegance, the Farey sequence appears in approximating irrational numbers, in the geometry of Ford circles, and even in the Riemann hypothesis. What began as an amateur observation remains a cornerstone of rational number theory, revealing deep order among the fractions on the number line.